Hello physics folk. In this video we're going to talk about the basics of vectors. So there's two main types of quantities we're going to encounter in physics. We have scalars, which are just numbers, things you've encountered before, such as 22 kilograms, 15 meters, just an amount, a magnitude. A new type of quantity we're going to use is called vectors. Vectors have both magnitude and direction, such as 22 meters per second north. Specify a direction. That's what's new here. So let's talk a little bit about those. But some basic terminology. Magnitude is just a fancy way to say an amount. So if I ask for the magnitude of anything, I'm just talking about how much is it. How many of them are there? 2 meters per second, 54 kilograms. Those are magnitudes. Direction, and sometimes we call it orientation, is just referring to, well, the direction, such as north or maybe 22 degrees, things like that. Now vectors have both magnitude and direction, as we said. When we draw vectors, we draw them as arrows, where the length of the arrow is the magnitude and the direction the arrow points is the direction. So let's try some vectors here. Which of these two vectors has more magnitude? So we're not talking about direction here, just the magnitude. And here it's pretty obvious that the one on the left has a longer arrow, therefore it has more magnitude. So what about these two? Well, the one on the right is clearly longer, so it has more magnitude. And these two, a little bit harder, but they're the same length. They're pointing different directions, but they're the same length, so that means they have the same magnitude. Now a bit about direction. When we're drawing vectors, we always have to draw both the magnitude and the direction. When we're measuring direction, we always start from the positive x-axis, which is 0 degrees. And then we go around counterclockwise to measure our direction. So we could have directions be anywhere from 0 degrees all the way around to 360 degrees. You can see in the picture there's some standard directions there, such as 90 degrees, 180, 270, as you go around. So you should remember those directions because it'll help when you're drawing the vectors so that you know where you are and what your answer should be between. So let's try drawing a vector. So if we're going to draw a vector that's 3 meters per second at 90 degrees, there's a few things we need to do in order to do this. Now it's hard to draw something 3 meters per second long on a piece of paper. What would that even look like? So first you have to define your scale. So here we're going to say 1 centimeter on our paper is 1 meter per second in the real world. Now we can draw meters per second. So let's pick a starting point. Vectors don't have a location, so you can start them wherever you want. So here I'm going to draw a coordinate plane, and we're going to start at the middle. Easier to measure our angles there. So we're going to start at the middle of this where these axes meet. Then you use a protractor to find the direction. So here we have 90 degrees, so we start at the positive x-axis, go counterclockwise till we reach 90 degrees, and then we draw the vector to the length specified by our scale. So our scale says 1 centimeter is 1 meter per second. We want 3 meters per second, so that's going to be an arrow 3 centimeters long, starting at the center of our axes and pointing in the 90 degree direction. So this is what we'd be looking for. And you'll draw all vectors like this. Could be 3 meters per second. We could be drawing in meters, which won't fit on our paper, so we'd pick a scale that would fit on our paper. Maybe 1 meter in real life is 1 centimeter on our paper. There's quite a variety of things you can do, but you have to define your scale. Otherwise, no one's going to know, are you drawing in centimeters? Are you drawing in meters per second? Are you drawing in kilometers? You have to define the scale. So we'll leave you with this. You've always wondered what a vector's favorite band is. Clearly, one direction. See you next time.